All right, so I get to introduce to you Greg Jones, and many of us know him as one of the world's great climate scientists. And not only that, he has built his career on giving insight to the wine industry, not just here on the U.S. West Coast, but throughout the world. He's a globally renowned scientist, but we're very privileged to have him here in our presence. He's a board member as well, and so join me in welcoming Dr. Greg Jones of Linfield College.
Good morning. Am I on? Good. Thank you. Well, I appreciate it, Mark. Thanks for the introduction, and it's a pleasure to be here. Sometimes, like last year, I travel in January, so it's better to be here in person because I actually get to see your responses instead of just kind of hearing things in the background. I need to mention something real quick about, I know this is something you're probably getting tired of hearing from or about. The government shutdown is affecting some of what I do, which is basically access to data, and especially data that is qualified, especially since the end of the year to today. But it's not only the government shutdown, it's also Brexit is causing problems in the UK. And the British government and the American government are pretty involved with finalizing climate data worldwide. And so what I've tried to do is put together the best I can, but you will hear me talk about preliminary and likely because some of it is just not final yet. But I'll see if I can walk around that the best I can here. So what are we going to try to do today? We're going to try to talk about where we are with the state of the climate, similar to what we did last year, look at a kind of a global down to a regional perspective, look at some current conditions where we are right now, and then talk about that in terms of kind of where we're likely to end up in 2019. So from a state of the climate perspective, this is one of the summary maps from a European agency. We're likely to end up 2018 to be a top 5 warmest year. Most evidence is pointing to it'll be the 4th warmest year on record, just below 2015 and 16 globally. Preliminary data does indicate also that the oceans, at least in the first 100 feet or so of the oceans, will likely be the warmest that we've ever had on record. So the oceans are absorbing a huge amount of heat, much more even so than the atmosphere, most scientists think. We also know that 2018 was one of the warmest years on record for the Arctic, and both poles are losing ice mass at record paces. If you look at the long-term data from multiple different locations, it clearly shows that we're still moving in this path of an upward trend overall. We're sitting somewhere about 1.1 degrees Celsius or about 2 degrees Fahrenheit above the long-term average for the past century and a half. If you look at the coterminous United States, this is some data, one of the regional climate centers for all of 2018. The preliminary data shows we're probably going to end up somewhere between 2 and about 2.5 degrees Fahrenheit above average for 2018. Likely the 4th warmest in the 124-year record of data that we have. And it appears to be that it will end up the 22nd consecutive year above average. And we had both above average maximum and minimum temperatures pretty much across the country. We do have a bullseye of relatively cool air that set over the northern plains, and we'll see that here a little bit more in detail. We also have some evidence that I think is kind of interesting when you go back and thinking about the framework behind El Nino and kind of how it represents a huge warming of the surface waters in the Pacific. Well, it's a big player in terms of global temperatures, and we know that 2017 and 18 were the warmest years on record that were not influenced by an El Nino. So even when the oceans are a little bit colder than normal, we're still seeing these increasing trend overall in terms of climate. If you look at California, this is just some data for June through August. These are just average temperature trends. And overall, from 1895 through 2018, 2.3 degrees Fahrenheit as a state in terms of the overall trend. but all climate divisions in the map over to the right on the image there, those are what the U.S. uses as a climate division for individual areas in the state. All of those climate divisions have warmed during the growing season from roughly 1.9 to 3.2 degrees Fahrenheit since 1895. If you look at this in terms of a distribution framework, I think it's pretty straightforward. Climate over a long period of time, temperatures, rainfall tends to follow a fairly normal distribution. But note that since 1995, only 1999, 2010, and 2011 have been below what we consider to be our 30-year climate normal for today. And that 2010 was 1.7 standard deviations below the mean. So yes, it was a cool year. But that 2012 through 2018 all are playing at about 2.3 to 3 standard deviations above the mean overall. If you look at precipitation, this is, again, all of 2018 preliminary data, and this is percent of normal for precipitation. And I think it's pretty clear. You can see the east was wet, and the west was dry. That's hard to say. But the continental United States will likely end up being all total above average in terms of rainfall, likely a top 25 year, mostly because of some of the large amounts of precipitation that came from both hurricane, tropical storm events in the east and south. The U.S. drought footprint is actually the lowest it's been in 19 years. This is largely because of what's happening in the east, and you'll see that in a minute as well. Western areas, though, have remained dry overall, and we'll see that some more as well. California annual precipitation for that 1895 to 2018 period is highly variable. There are no trends in general in annual precipitation, and all divisions show this kind of highly variable kind of framework in terms of precipitation. There are some minor trends in some regions and in some seasons, but it's not an overall signal that we've seen in general. And you can see the period of the past decade or so where we've been quite dry. I'm just going to make a statement a little bit about what I've watched and kept track of for the vintage across the western United States in terms of just general influences. This is an interesting year. 2018 was pretty consistent across grape-growing regions across the West. Normally, there's some differences between the North and the South and Washington, Oregon, California. But this year, everybody was pretty close to what I'm about ready to go through. First of all, we ended up last winter with a minor La Nina, which gave us a reasonable moisture in the late winter, early spring. And so we had decent soil water potential in the start of the growing season. But it ended up being overall much drier. I don't know, I heard the news, but the many, many stations across the United States had their longest period without rainfall. Anywhere from 90 to 132 days was the longest that I heard in the western United States. We had a fairly cool April, warm May and June, and generally a good fruit set pretty much west-wide. There was a few places here and there that had some issues, but generally pretty good overall. Again, a fairly warm and dry summer, but here's the real key. There was low heat stress pretty much throughout the entire West. We just did not see heat extremes like we saw in 2017 or even years before that. We also had a slightly higher diurnal temperature range because of summer nighttime temperatures were a little bit cooler than normal. And most of that, I think, was caused by some fairly strong coastal upwelling off the coast of both California, Oregon, and Washington. Coastal upwelling comes typically from fairly strong winds that blow along the coastal zones and typically brings colder water to the surface. And I think this was really probably the main player that kept heat stress events at a minimum this past year. We also had a fairly decent cool down in September. I think everybody kind of was really welcoming this, and especially places up north where we actually had first rainfall in 100-plus days in some places. We had a fairly slow progression through harvest. I think most people would say it was a pretty nice harvest, and then October recovered and made it a lovely finish to the season as well. From what I'm hearing from pretty much everybody, we still have statistics coming in. And again, government shutdown causes some issues with this, but likely we're to see a crop that's going to be somewhere between 5 and 15% up over previous years in the Washington, Oregon, and California areas. So current conditions, where does this kind of put us right now currently? Well, this is the ocean temperature departures currently right now. The North Pacific has been very warm. As a matter of fact, from roughly, I think, June through December, the upper 300 feet of the North Pacific Ocean was the warmest it's been since we started taking records back about 50 years or so ago. It's also displaying what we call a positive Pacific decadal oscillation, just basically meaning that there's really warm water in the Gulf of Alaska and along the western United States overall. We also have the tropics that have transitioned from a neutral ENSO characteristic during the summer to a moderate, weak El Nino currently, and the waters you can see across the tropical zone are fairly warm. Both of these are factors that tilt kind of the characteristics of what we would expect from our climate. We'll talk about that a little bit more. I wanted to show a couple of different diagrams here, just looking at the Pacific, and show you how differently the Pacific can look in just a year's period of time. We're talking about temperature differences on the order of between 1 and 3 or 4 degrees near the surface, and you can see the relative warmth over much of the Pacific in where we are currently, whereas clearly the La Nina conditions in the tropic with relatively cold water last February. So if we're in this framework where we have an El Nino, weak, moderate, and then positive PDO, what do we kind of expect over the western United States? And again, this is what we expect, and doesn't always play out perfectly. But typically, in an El Nino winter, as we go in from winter into spring, we would see that the Pacific Northwest typically is warm and dry. We would see that California has this kind of pattern of either being kind of really close to normal temperatures to slightly cool, and really close to normal precipitation to extremely wet. And this is because not all El Ninos are created equal. We have a tendency to, when they're fairly large events, they tend to be much more effective at producing differences in California. And we're in a fairly moderate, weak framework right now. There's a transition zone about the California-Oregon border in which these effects kind of flip-flop north to south. So what are we seeing right now? So this is I just pulled this data down the other day, and this is the current water year, October 1st through January 21st. The temperature patterns we're seeing right now are relatively warm across the west, except for in the Great Basin, which has been relatively cool. And these are pretty close to what we would expect from a weak to a moderate El Nino winter. The precipitation pattern is also somewhat close to what we would expect, except for California is moderately drier than we would see in a slightly stronger El Nino kind of framework. Snow water equivalents across the west are average to just slightly down, depending on location. Every one of those areas that's in the kind of the light blue to the green are near 90 to about 100, 110% of average snow water equivalent. It's a good thing. Places in the yellow and in the kind of burnt orange color there are places that are a reasonable amount below average right now. We still have some time for accumulation, but really roughly 3.5 or so months. So let's keep our fingers crossed. I know you guys have seen this diagram before. This is the Northern Sierra 8-station index that people tend to monitor for water availability in the Sierras. We're currently sitting right near average, long way to go, but you can see kind of the framework there. The blue area is the average window or the average accumulation amount, and you can see where we were in the really wet winter of 2016-17, and then really dry winters as well, like 76, 77. This does lead us to where the drought monitor is. I mentioned just a little bit ago that we're currently at the smallest drought footprint the U.S. has had in quite a long time. And you can see it's mostly because the eastern United States is largely free of any overall drought concerns right now. The west drought footprint has continued. The Four Corners, that bullseye on the Four Corners, has been there now for about 6 or so years. But you can see that the west is still relatively dry. And our fear up in Oregon and Washington is that this drought is likely to continue through this winter and into the summer. It's pretty evident. If you look at California reservoirs in general, they're averaging 63% of total reservoir capacity right now, which may not sound like a lot, but it's all about planning for water because they're actually at 98% of the historical group averages. So they're basically holding a certain amount of water currently right now, expecting more input over the course of the rest of the winter and into the summer. This is just slightly less than what we had last year at this time. There's still plenty of time for rain inputs, but there's some indication that we might not have very much here coming in the next month or so, so we'll talk about that as well. So to kind of put this in some general perspective and tie it into the broader picture and then get down to kind of what I think is going to happen here coming up. Number one, we've had some substantial variability in weather and climate worldwide for quite a long time, but 2017 was definitely a couple of years that really saw much more than average. We currently know, if you look at all of the forecasting agencies across the globe, that the Pacific Ocean is a major, major player in the overall patterns of temperature within the global perspective. With the North Pacific being warmer than average and El Nino in the tropics, everybody is pointing to the fact that 2019 should be a top 5 warmest year again. And a lot of this is by looking at really persistence in the climate system. We don't think it can flip-flop in any great way, and so that's why we're tending to point it to be very close to 2015 and 16. And the Met Office in the UK, who I've been working with closely on a couple of different projects in Europe, they release this forecast for global temperatures each year about this time. And they frankly have been spot on. The little green area there to the right for 2019, that's their margin of error, so to speak, in temperatures. And I haven't seen them fall out of that margin in about 10 years now. So they're pretty much spot on. So the UK Met Office is showing that, again, 2019 should be a top 5 warmest year on record. So weather extremes in the United States, I didn't have a diagram to show you in terms of this, but we have seen climate extremes be much higher than normal in the past 20, 30 years than they have over the past 100 years. And it is especially true, I think, coming up for 2019. All of the evidence is pointing to especially the southern tier of states having a much higher climate extreme framework in 2019. As I showed you just previously, the spatial extent of drought in the U.S. has declined, especially in the south and east. However, we need some snowpack here in the west. We need, it would be great if we could get about 150% of normal west-wide, but not real confident about that right at this moment. You probably have also heard the term the ridiculously resilient ridge. That's a hard one to say 10 times too. I don't have a diagram on this because the again, government shutdown kind of limited some of the data that's out there. But you guys just went through a period of time where you got some rain, right? Feel pretty good about it. Well, it's going away. Yeah, it looks like 10 days at least of fairly dry weather is coming into place with a ridge that's building in over the western United States. And what's going to happen back east is that they're going to be cold, bitter cold, with lots of snow. And so we're moving into this ridge troughing pattern, and some people are forecasting that will break in about 10 days and maybe bring us a little bit more rain in the west. but there's some longer-term models that are currently showing that this ridge trough structure may be in place for at least a month or more, which means of February, which is typically relatively wet in the western United States, might be quite dry. So we really have to kind of watch the next few weeks in terms of how this ridge sets up and what it produces for us. I do think that currently right now with the Pacific, North Pacific the way it is, and the tropics, that we're likely to continue to see fairly dry and warm conditions across the northern tier of states in the country, and then a relatively cool-ish, if that is a word, to wet conditions across the southern tier of states. If you look at NOAA and you pay very much attention to this, this is one of the critical pieces of the Center for Climate Prediction that is still functioning with the government shutdown. This is the current March, April, May 90-day forecast window, and they're basically showing that they're indicating that we're likely to have a warm west and southeast with equal chances in between, no real dominant thing going on in the center part of the United States. But if you look at this as you go further into the summer, the probability increases for a warmer western United States. Rainfall, March, April, May, has kind of a mixed pattern across the country, with some of the south likely to be wetter than average, but much of the country doesn't have a lot of evidence right now of us going to be much different than being slightly wetter or drier. The Pacific Northwest is likely to remain dry, and the pattern continues through April, May, and June. Both of these resemble what we might see in a weak El Nino kind of framework, and so I think these forecasts are really being driven by what's happening in the tropics, which means we really kind of need to pay attention to that. If you look at the seasonal drought outlook that was just released on the 17th of January, everything in the brown is indicated as drought persistence is likely. Part of the good thing for, I guess, the Four Corners area is that there's drought remains, but it's supposed to improve for a large portion of that area. But much of the West is likely to stay within drought categories. Parts of Washington, Idaho, and Oregon are likely to develop more extensive drought and add to this concern overall. So if you put all this together, and I know I'm repeating myself a little bit, but hopefully this will hit home. For the western United States overall, this is what I'm seeing. Tropical sea surface temperatures transitioning from El Nino to neutral during the summer. I don't think that's going to play a huge role in what's happening, but it definitely is a piece of things. The North Pacific, I think the sea surface temperatures there are likely to stay in place for quite a long time. There is some indication, early indication from buoys that coastal zone upwelling could kind of come back in this coming summer, which basically means we might have a warm year, but a year of lower heat stress. That's kind of the take home from that. If you put this all together and you look at it, what it really means, I think it tilts the odds to us seeing a California that is cool with normal precipitation to slightly drier from here to mid-spring or so. The Pacific Northwest is likely to stay much warmer than average and dry from the late winter to early spring. If you look back at historical data and you try to look at analogs to try to figure out kind of what this means for certain things like spring frost, frequency and severity of spring frost over the entire West tends to be lower in years like these. However, the probability does increase as you move northward and inland a little bit. Growing seasons with these kind of conditions and analogs in years past always tend to be warmer. And persistence in the climate system definitely is tilting the odds to 2019 being similar to 2015 and 16. But increasing drought conditions, especially in the Pacific Northwest, are really a concern. I think we all know it, that the fire seasons of late have been quite severe, and this summer I can see those occurring again pretty clearly. So with that, I appreciate it and welcome any questions you might have. Thank you.
At what point do you feel global warming we're over the tipping point?
The question was basically about the issue of climate change, global warming, getting to a point where we're over the tipping point and there's no return. It's a big question. If I had that answer, I just don't know. The issue is that how resilient is the atmosphere and the Earth's surface? I think one of my biggest concerns right now are the oceans. They have absorbed so much more heat than the atmosphere has in general. And they're the basic buffer for a lot of what happens climatically. And if our oceans continue at that rate, we could be having some real issues. The other piece of this I think is really important. We live in the mid-latitudes where our climate is really driven by what happens in the polar regions and the tropics. The poles have warmed so much that the gradient between the poles and the tropics is completely different today. And that causes this increase in variability. And so if we continue to lose ice mass and continue to warm, our seasonality differences are going to change as well. And so those are the things that, are, at least on the short term, are really concerning. But again, I'm not sure where that tipping point is. We could be pretty close to it from what some scientists are saying. Okay.
Are there any trends for the duration of the dry period during the summer?
Well, in some places across the West, yes, we've seen this. All growing seasons, if you took measures of growing seasons, say like critical temperature points in the spring and the fall, all growing seasons have expanded in length. And so that right there in and of itself is one piece of the evidence. The other is that the number of days without rainfall during the summer period, and we're a dry summer climate anyway, but that has expanded in most places out there. It varies a little bit from region to region, but it has expanded in general. Yes, sir.
Following up on that is, we talked a lot about overall rainfall. What about changes in the trends with intensity and frequency of the rainfall and timing?
Sure.
Has that changed?
So there's evidence worldwide that rainfall events that used to be fairly frequent at low intensity levels have actually declined. We have fewer rainfall days, but more rain during individual events. And part of what we think here, and dynamically it makes sense, a warmer atmosphere is an atmosphere that turns over quicker, meaning it can hold more moisture, but it tends to want to get rid of it quicker. And so the hydrologic cycle tends to be much quicker, so the residence time of moisture in the atmosphere moves through it much quicker. And so that would tell us that, yes, we have fewer events. Fewer heavy rain events. No, going the other way. More heavy rain events and fewer small events spread out over the year. And part of I know that you guys hear this probably in the news as well, these atmospheric rivers, when people talk about kind of this framework. These have been with us forever. They're not anything new. It's just that the media has kind of gotten into it, and we hear more about it, so we think that there's something that they're new. But what we do know is that the patterns of them and the amount of moisture they contain are now more than they used to be. And so we're still likely to see them, but we may see more of them and have really heavy rain events out of them over short periods of time. Okay. Looking good. Thank you very much.